Okay, welcome back. I'm running a couple of checks on a few of these C# nodes I got from Rajaa Issa's white paper, and I thought it was pretty good. And I just want to show how a few of these work. So what you want to do is, we'll just take a look at what I'm looking at as I'm looking at it. And we'll pull that down into, actually, I think artistic's fine. You see how it's kind of split at the zero plane. So the first item is pretty simple. What I've done is I have an add points algorithm. Now this is hopped up, so all these scripts are actually a hop script that I've just set to a name, add points, which was the script that I wrote out of this points one here. And I wrote a lot of scripts to learn C# through a lot of different programs, Warsaw, Rajaa Issa, and I still have a lot of improvement to do, but translating C# books of GHPYTHON books, or Python books, should be fairly easy enough for me. Getting them into Grasshopper is one thing, and then bringing them into hops is another. So this is literally hop to a path on GitHub that's live, and it goes right to my GitHub page and goes to users and hops up. This one technically is on my desktop. I actually haven't hopped it up yet, but I'm prepared to do that. What I've been trying to do is find out which ones are worth, which algorithms are worth playing around with. This one's the blue one right now, and you can see I just have a grid of points, and what it does is it adds those points to those points. You start with these points on this cell, these points on this cell, you add them together, and you get these points to drive geometry. So I'm starting to drive geometry by hops through C# scripts that Rajaa Issa had put out. And these are my favorite ones, the ones I'm going to use. This one's a nice line, which basically just has 2 points that I'm just iterating through some. I did this because I thought it might be cool to like plug all 3 of these in here. Give it a second to run. What it's doing is kind of overriding and putting in a list instead of list item into here. And a little slow down here. We'll give it a second. And you can see how these can have an effect on list items and then what drives that. And then I also can go in and I can have some fun with grafting a few of these to get different data as well. So you can play with this node. It was pretty simple to start, just 2 points generated, and then it finds the line curve between them and actually makes a NURBS curve between them. So you have 2 types of curves, and it can get as complex as you want it to be. So I like that little script. It's called Convert Line Curve to NURBS Curve, which is kind of nice. All right. And once again, you can go into here, and what I'm going to do is take the path, and instead of have it go to this file path on my computer, I will just quickly go into GitHub, and what I've initially done is, let me have a second to load this up. 1 sec. Now I've left a couple public, and this is one I left public for basic C# scripts, which you can go into, pick one that you actually like using. There's a do while loop. All you have to do is right click and copy the link. So currently right now, and then those links can be brought in, put right into here, so you don't have to go to my desktop, you can go to GitHub. I haven't, with these 1, 2, 3, 4, 5, 6, 7, they're the beginning of picking and choosing the geometry C# scripts I think will be useful for amping up and really getting my Grasshopper scripts doing more jive. So I've only selected maybe 4 in here that are useful. Most of them were to learn C#, so they're very similar to the vanilla or Grasshopper regular ribbon nodes. So there's no reason to hop to them when you have them on your ribbon. But some of these are pretty unique, and I'll show you which ones I like, obviously. So this one's okay. It just does something with lines. This is the next one, which is a great ellipse curve. It's not as good as making a conch, but I think it's a fun little exercise to go in and be able to rotate through and change your pie and hop to that one. So I call that rotating ellipses, which is just a fun little unique geometry. It's kind of too specific a plugin to be really worth playing with. But I thought, why not bring it in there to show? And once again, that one will be, that's rotating geometry, and there's many ways to see it. You'll end up downloading and bringing it in, and your script will look like this when you bring it in. But then you could always change it to whatever name you want to make it useful for yourself. And I think that's really cool, because then you're, and then if you ever wanted to really get at C# nodes, just contact me on Patreon. I've got all those C# hopped up nodes and clusters so you can learn how to write C#. This is pretty basic. You can figure out most of this stuff from a textbook. The next one is a mesh method point distance, which basically gets yourself a bunch of points and then finds the difference between those points. Now they happen all to be right at the center, so it's not that interesting, the point difference, but you can find a way within this script to generate a lot of different things by moving these points around. And you get a variety of distances within them. I didn't output the distance for some strange reason, so I'm probably going to have to fine tune and go back to my C# node and see what was going on there. So this was method point distance. Method point distance. Oh, you can see how confusing it got for a while. And actually it would be under points, not under curves. This one. So this node really should be giving me a distance out, and I forgot to do that here. So I have to go back in and make sure I hop to that distance script. So I'll do that before I'll just put a little red on here to say, yeah, I've got a little work to do on that. Let me jump to color, and I'm going over my other screen so you can see what I'm doing. I'll put a little red on there because that means I have something to fix, and I just have to remember what that was. So I want that distance. Here's one that needs a curve or it needs a geometry. So any surface that you end up constructing in Rhino. So what might be nice is just to take this, go back up to this shell. It might be kind of cool to just pull that surface out as reference to here. Let's pull that shell out. Let's bake that geometry. And actually, let's just take that. I don't need to bake it. Just take it and plug it back into our surface here. And now I should be able to grab an ISO curve on that, so long as I have reparameterized that. I think it's automatically reparameterized because I tucked it into the hopped up script and the C# script. Now, if this isn't making sense, you really have to just kind of get into it, because I have this way of grabbing this 0 and then any ISO curve I want. Now, that's not as good as just grabbing ISO curves, but maybe you just want to grab it in one direction. You want to have your own little hopped up script to play with all the time and call it whatever you want. The next one is here, which is what geometry is influencing that. It's a vector, and here it is, very, very tiny. It's a small little tiny curve that I generated, so it's probably best to just put it on which curve that I've done, this little tiny helix, and then I've gone and grabbed the vector at the beginning of that curve. So you have to look at that original line. It doesn't output the line, it just outputs the start point. So you can see the start point, the curve, and that start. Now there is a tangent vector at lines, so you don't really need this. I think in curve tools analysis, curve parameter, evaluate tangent. Oh, it's around here somewhere. I just have to find it. There's a really nice utility in here. Curve to polyline. Oh, I just can't remember where it is. I'm sure there's a tangent tool in there that I was using before for analysis, and it might actually be in vectors. Anyway, if you want to get into these are offset curves. So offset curves are kind of nice, one side, two sides. You can play around with this one. You need a curve to basically bring it out. It defaults to the curve that's actually in the C script, but then again, you can grab whatever curve you want and offset those curves. So say I use that one, it'll take a second to load, and there's that crazy thing happening here that my tolerance is set. It's a little wide. It's going to take a little bit to run. And what you can do is, and on all these hops nodes, which is actually recommended, is a synchronous. I never can say that right. I can say synchronous, but I can't say asynchronous. I should be able to. So let's just pull that in and then shrink that down. And you'll see how that runs to the last script as we go. I think I fudged out there a little bit. And when you do override your C# scripts, I'm trying to push the C# scripts as best as I can. And then I'm just going to bring that in so it's less of a count. So just 2 count between them. So what happens to that helix from that point? Probably have to reduce this because of the size and scale. Anyway, those are my kind of favorite ones. And what I'm trying to do is go through Rajaa Issa and take a look at all the work I did in C last summer, look through the points and find out which of these nodes are not in Grasshopper, but I think could be useful for, certainly it was useful for getting me to read the C script so I can start to input any C script. As I go through curves, I've pretty much gotten through that section. We're going to obviously go into surfaces next. I'll see if any of these methods or things on surfaces is worth making, even though most of them are just tests and making the vanilla nodes. And that's about it. So I think it's pretty exciting to think this way, to think that you actually gain a little bit of control, a little bit of programming understanding, and you're working a lot more computationally in your plans and designs. And like anything that I've studied online, it is about your design first. What are you going to do with it? I want to grab that little blue one, just my little surface. There it is. And then knowing how to do it after you know what you want to do and why you want to do it. Okay, thanks very much for watching. 10 minutes.